Good morning, Nana. Today we'll start LAQ's continuation. Question number 5. Question number 4. Question number 4. LAQ's Demoivre's theorem. Question number 4. Question bank problems only. So show that already we learned this one. Again I am explaining. 1 plus cos theta plus I sin theta whole to the power of n plus 1 plus cos theta minus I sin theta whole to the power of n equal to, we have to prove 2 to the power of n plus 1 into cos to the power of n of angle theta by 2 into cos of n theta by 2. So show that 1 plus cos theta plus I sin theta whole to the power of n plus 1 plus cos theta minus I sin theta whole to the power of n equal to 2 to the power of n plus 1 cos to the power of n theta by 2 into cos n theta by 2. So same thing. So basic from trigonometry formulas we have to apply here. So that is 1 plus cos theta formula and sin theta formula we have to use here. So that is 1 plus cos theta. So 1 plus cos, first to write down the formula. 1 plus cos theta from trigonometry. So that is write as 1 plus cos theta equal to 2 cos square theta by 2 and sin theta equal to 2 sin theta by 2 cos theta by 2. Already we know these formulas. We know that these values 1 plus cos theta equal to 2 cos square theta by 2 and sin theta. This formula is from 1 plus cos 2 theta, that is 2 cos square theta. It is half angle. So write as 2 cos square theta by 2. Sin 2 theta, 2 sin theta cos theta. From half angle means 2 sin theta by 2 cos theta by 2 have to write. So take LHS, that is 1 plus cos theta plus I sin theta whole to the power of n. So that is, this is the real part and this is the imaginary part. With I term is there, so that is why it is imaginary. Without I means it is real part. So substitute in the formula 1 plus cos theta, that is 2 cos square theta by 2 plus I into sin theta means write as 2 sin theta by 2 into cos theta by 2. As it is formula you should apply here. That's all. Then 2 cos theta by 2 is common. From this both them we have 2 cos theta by 2 common. Then you get cos theta by 2 plus I sin theta by 2 is the remaining. So that is whole power n. So nothing but, so 2 to the power of n cos to the power of n as power na. So write as cos power n of theta by 2. Theta by 2 angle. And this is in the form of Demoivre's. What is the formula Demoivre's? Cos theta plus I sin theta whole to the power of n as replaced as cos angle joined with augment plus I sin n theta. So that is here angle is theta by 2. So same thing, join with augment cos n theta by 2 plus I sin n theta by 2. This is the term of first expression. This is the value for first one. In the same way we have to write as 1 plus cos theta, 1 plus cos theta minus I sin theta. In the same way we have to write same thing, just replace by minus, plus as to minus, that is, so 2 to the power of n cos power of n of theta by 2 into same thing, just write the rechange as to minus only. So cos n theta by 2 minus I sin n theta by 2. So this has to second expression. So write as, don't write as it is, just replace by plus as to minus. So first what we have done, 1 plus cos theta equal to 2 cos square theta by 2 and sin theta equal to 2 sin theta by 2 cos theta by 2 as the power of n. So 2 cos theta by 2 as common, then cos theta by 2 plus I sin theta by 2 whole to the power of n. That is 2 to the power of n. Power goes to this term, that is 2 power n. This power also goes to cos power n theta by 2. This is under the formula, that is cos theta plus I sin theta whole to the power of n. So join with its argument, it is theta by 2. So cos n theta by 2 plus I sin n theta by 2. So this expression as first equation. In the second way, LHS, RHS, LHS 1 plus cos theta minus, just replace by plus, there is no change, just in between plus as to minus. So write as same thing, plus as to here minus. Now add first expression plus second expression. Then you get LHS. So that is why I am writing the next page. Just all of you please make a note. What we have done, just based on only these formulas, and this is the Demoivre's formula, that's all. Now we have to add that both terms, that is in the both terms we get 2 power n into cos power n of theta by 2 as common. Then add these terms, that's all. So first expression as 1 plus 2, 1 plus 2, that implies 2 to the power of n of cos power of n of theta by 2 common. Then you get cos n theta by 2 plus I sin n theta by 2 minus plus cos n theta by 2 minus I sin n theta by 2. Now get cancel of the terms, sin terms will be get cancelled. That is implies 2 to the power of n into cos power of n of theta by 2 into cos n theta by 2 cos n theta by 2, that is making 2 cos of 2 cos n theta by 2 as usual formula. So that is nothing but here 2 is there, 2 power n is there. So base are equal, power should be added. That is 2 power n plus 1 of cos to the power of n of theta by 2 into cos of n theta by 2. It is in the angle n theta by 2. This is the power as n. Cos power of n of theta by 2. This is cos n theta by 2. In the terms will be get cancelled. Then you get 2 cos n theta by 2 cos n theta by 2 cos n. So this 2 and this 2 power n making 2 power n plus 1. That's all. This hence proved. So what is the question is given? 1 plus cos theta plus I sin theta whole to the power of n plus 1 plus cos theta minus I sin theta whole to the power of n equal to this. So this already proved. So that is why we have to apply. This is based on the trigonometry formula. 1 plus cos theta 2 cos square theta by 2 sin theta 2 sin theta by 2 cos theta by 2. So 2 cos theta by 2 common. So that is you get 2 to the power of n of cos n cos to the power of n of theta by 2 into as per Demoivre. This is first expression. In the same way second expression, then adding the terms in between plus is there. So write as to plus. So both expressions should be adding. So then you get 2 cos n theta by 2, that is making 2 to the power of n plus 1 of cos power of n into theta by 2 cos of n theta by 2. That's all. These 7 marks is questions, just a simple questions. We can practice more. Very easy questions. Then go to fifth question. Question number 5. N is a positive integer. This is also same thing. P plus IQ whole to the power of n. P plus IQ. Question number 5. Show that P plus IQ whole to the power of 1 by n plus P minus IQ whole to the power of 1 by n equal to 2 times of 2 into P square plus Q square whole to the power of 1 by 2n into cos of 1 by n into arc of tan of Q by P. So don't worry about this arc. Arc means tan inverse. In first year trigonometry we learn inverse trigonometry function. It is denote inverse or else arc, both are same. So just prove that P plus IQ whole power n plus P minus IQ whole power n equal to 2 times of P square plus Q square whole to the power of 1 by 2n into cos of 1 by n into arc tan inverse of Q by P, that is. So same thing. So any first this number LHS you have to take, that is LHS P plus IQ whole to the power of n is there. So now first consider this P plus IQ, that is in the any complex number represent as modulus amplitude form. That's why we are writing to modulus amplitude means r into cos theta plus I sin theta, that is r into cos theta plus I sin theta form we have to convert it. So that is where r equal to here what is modulus means root over p square plus q square into, so that is cos theta we have to simplify. So that is why I am taking as 2 now. For this simplification I am comparing with this equal to, whereas p equal to r cos theta and comparing on both sides, that is q equal to we get r sin theta. That's all. So why? Because I am taking in the terms of tan is there, that's why I am taking. So that is tan theta means we get how will you get sin theta by cos theta, that is sin theta by cos theta, meaning that we can write as sin theta means here q by p. So this expression dividing, so that is tan theta equal to q by p, then theta equal to write as here tan inverse of q by p, that is nothing but arc tan inverse of q by p. In terms of q by p we are following. So that is theta equal to tan inverse of q by p. In the first in the question is given, that is why we got that. And remaining part for our convenience write as to cos theta. So cos theta is nothing but write as if it is theta here theta. So tan theta means q and this is p and this is equal to root of p square plus q square. Then you write here cos theta equal to write as p by root over p square plus q square basic one. And sin theta also write as q by root over p square plus q square. I am not writing directly, just I am saying why purpose we have to write here. So r into cos theta plus I sin theta, where r equal to modulus means root over p square plus q square from that point p comma q, and sin theta means we can get as to root over adjacent by p by, this is tan theta nothing but q by p nothing but this is q and this is p, and root over p square plus q square, and cos theta equal to p by something and this is equal to q by. Just I am replacing in these terms in the modulus amplitude form I am writing. So just what I have done again. So b plus iq is nothing but write any complex number in the modulus. R is the modulus, theta is argument, we can write as p plus iq equal to r into cos theta plus I sin theta. So comparing p equal to r cos theta, q equal to r sin theta. We in the form of question is the tan terms, that's why I am taken as r sin theta by r cos theta, means r will be cancelled. Then sin by cos equal to q by p, then tan theta equal to q by p, then you get theta equal to arc tan q by p or else tan inverse q by p. From this cos theta we can write as p by root over p square plus q square, and sin theta nothing but q by root of p square plus q square. In terms of all terms in the p terms I am converting, that's why I am writing on all these as to in the form of sin theta and cos theta. Now substitute in this p plus iq I am writing as to r means we are writing modulus means root over p square plus q square, and this has to cos theta, that is p by root over p square plus q square, and this is as to q by root over plus q square. Okay, or else we can write as simple form root over p square plus q square into nothing but cos theta plus I sin theta in the short form. So nothing but in the expression this is belongs to p plus iq. In the question it is given that p plus iq whole to the power of 1 by n. That is why we can write as root over power in power raised to p square plus q square. That is why I am writing whole power 1 by n into cos theta plus I sin theta. Already the power goes to whole power 1 by n. Now rewrite as root over p square plus q square whole to the power of 1 by n into cos of theta by n plus I sin theta by n. This has to convert, just directly convert as, this has to write as while the root form will be deleted, then you get that is 1 by 2n. Square root means 1 by 2n. This has to p plus iq whole to the power of 1 p by q 1 by n. Similarly, p minus iq whole to the power of 1 by n write as p p square plus q square whole to the power of 1 by 2n into, just replace by plus as to minus cos theta by n minus I sin theta by n. This has to second expression. So that is nothing but we can add 1 plus 2. So that is p plus iq whole to the power of 1 by n plus p minus iq whole to the power of 1 by n. That is nothing but in both terms this term should be common. That is p square plus q square whole to the power of 1 by 2n as common. Then you write first term as cos theta by n plus I sin theta by n. Here write theta by n. Theta by n. Here also theta by n. Plus cos theta by n minus I sin theta by n. Now sin terms will be get cancelled. So that is p square plus q square whole to the power of 1 by 2n into cos theta by n 2 cos theta by n. Now just replace as to theta means what we write here. Theta means we convert it. That is in the question already we proved, that is theta means what you have converted. So in terms of p nothing but in terms of tan it is already proved, that is 2 means about outside, then 1 by as 1 outside, then cos of theta means tan inverse of q by p, or else tan or tan, both are same. That's all. This is question carries 7 marks. So in previous what we have learned, p plus iq whole to the power of 1 by n plus p minus iq whole to the power of 1 by n equal to this term we have to prove. So any complex number in the form of r cos theta plus r sin theta, that is r into cos theta plus I sin theta, where p equal to r cos theta and q equal to r sin theta. From this I am doing for in the terms of tan means r sin theta by r cos theta, that is nothing but q by p. So that is tan theta equal to q by p, then theta equal to that as tan inverse of q by q. Wherever cos theta we can write as p by some root over p square plus q square, sin theta nothing but q by root over p square plus q square. So this only, all these I am substituting in the expression p plus iq. That is r means modulus, cos theta means this, sin theta means this. I am not writing this total thing, indirectly write as cos theta plus I sin theta, nothing but both are same. So p plus iq power raised to 1 by n now. So that is p square plus q square whole to the power of 1 by n into cos theta plus I sin theta whole to the power of 1 by n. So that is p square plus q square square root means 1 by 2n into cos, as per Demoivre's cos of theta into 1 by n means it is joining with argument cos theta by n plus I sin theta by n. So that is p plus iq whole to the power of 1. Same similarly, when p minus iq whole to the power of 1 by n nothing but just replace by minus. This expression means 1 plus 2. That implies we get p plus iq whole to the power of 1 by n plus p minus iq whole to the power by n in the LHS. So in both terms this term should be common. Cos theta by n plus I sin theta by n. Similarly this terms sin term will be cancelled. So 2 cos theta by n. Where theta is there we have to write as tan inverse of q by p. 1 by n as outside. 2 times is there 2 outside. That's all we have proved. Same thing, all are in the method only same. So now going to the next question. Question number 7. In the same way it is given x power m comma n are integers, x equal to cos alpha plus I sin alpha, y equal to cos beta plus I sin beta. Then prove that x power m into y power n plus 1 by x power m into y power n equal to 2 cos m alpha plus n beta, and x power m into y power n minus 1 by x power m into y power n equal to 2x sin of m alpha plus n beta. Same thing, all these are in the method same, very easy chapter. So practice more Nana again. So our next question, question number 6. Question number 6, it is given that 6th question. M comma n are integers. M comma n are integers. Then show that x equal to given as cos alpha plus I sin alpha. X equal to cos alpha plus I sin alpha. And y equal to given as cos beta plus I sin beta. Then prove that, then we have to prove x power m into y power n. So x power m into y power n plus 1 by x power m into y power n equal to 2 cos, very easy as question, m alpha plus n beta. In the similar way, x bar m into y bar n minus 1 by x bar m into y bar n, that is 2y sin m alpha plus n beta. We have to prove. That's all. Very easiest question. So that is x is given, y is given. Power raised to m. So that means cos m alpha plus I sin m alpha. Just you think, Nana. Y bar n is given, that is cos n beta plus I sin n beta. Why? Because it is in the form of Demoivre. So join with its argument with as the power. So multiply. So nothing but this has to cis m alpha, this has to cis n beta. Now multiply x bar m into y bar n, nothing but cis of m alpha plus n beta. And similarly 1 by x bar m into y bar n, nothing but in between plus has to write as its conjugate minus. Then add the terms. Sin terms will be get cancelled. Then you get cos of 2 cos of m alpha plus n beta. If it is subtracting, then you get cos terms will be get cancelled. Then you get 2y sin of m alpha plus n beta. That's all. Very easiest question. So this carries also 7 marks. Just apply the Demoivre's are you understood or not? Just you are taking. Simple thing. So that is right as x is given as so given x equal to cos alpha plus I sin alpha. Now write as x power m is given, power raised to m, that is write as x power m, that is cos alpha plus I sin alpha whole to the power of m. Now therefore x power m equal to write as the power will be joined with the argument, that is cos m alpha plus I sin m alpha. Why? Because writing it in the form of Demoivre's formula. Next here what is given, y equal to cos beta plus I sin beta is given. Now in the form of question is given y bar n. So power raised to n, that is cos beta plus I sin beta whole to the power of n. Now write as y bar n, therefore y bar n is nothing but as per Demoivre's cos n beta plus I sin n beta, power joining with the angle. So next in the question, just question, read first question, anything, any question is given, it is IP or objective or any question, read the questions carefully, then you get what we have to do, then step by step we have to solve. So x bar m into y bar n. Now x bar m into y bar n, that is I'm writing here in the short form cis m alpha. This has to write as cis n beta. Okay. Now write as x bar m into short form only use, we can write as simple way. So cis m alpha into cis of n beta. Now it is in the form of cis alpha into cis beta. Basic formulas we can apply here. That is nothing but cis of m alpha plus n beta. Cis alpha into cis beta formula is cis of alpha plus beta. Here m alpha plus and n beta is there. Cis of m alpha plus n beta. Now we expand cos m alpha plus n beta. This is plus I into sin of m alpha plus n beta. So this is the form of x power m into y power n. But we are in the second, in this question 1 by is there. 1 by x power m into y power n is nothing but same thing you write cos m alpha plus n beta. Just replace 1 by means 1 cis of minus theta na formula. Just that's why we are writing minus I into sin of, in between minus will be right. Cos m alpha sin of m alpha plus n beta. Then what we have to prove, x bar m into y bar n plus 1 by x bar m into y bar n. So from this term and this term should be adding. So same thing. So just adding this term, sin terms will be cancelled. Then you get 2 cos m alpha, hence proved. If it is minus, we are doing subtraction. Sin term will cos terms will be get cancelled. Then you get sin terms as 2 terms. That is 2y sin m alpha plus n beta. That's all. This carries 7 marks question. Very easiest question. What we have done here, x equal to cos alpha plus I sin alpha. Now as power raised to m is given, that's why we are writing x power m. As per question we are going. So cos alpha plus I sin alpha whole power m. So nothing but cos m alpha plus I sin m alpha, which is nothing but cis m alpha. And similarly, y power raised to n, nothing but cos beta plus I sin beta whole to the power of n. Y power m equal to cis of n beta. So in both terms, next go to in the question x power m into y power n, that is cis m alpha into cis n beta, that is cis of m alpha plus n beta. Just expanding cis cos m alpha plus n beta plus I sin m alpha plus n beta. In similarly, question is given 1 by, that is in reciprocal, 1 by x power m into y power n, nothing but we are right as just replace the sign as to minus. That's all. Then go to the, by adding this expression we have to add. So that is in, then you get this alpha. So write as in the next page. So that is x power m into y power n plus 1 by x power m into y power n, nothing but cos, writing is so lengthy but problems are very easy, plus I sin of m alpha plus n beta plus cos m alpha plus n beta minus I sin m alpha plus n beta. Now which terms will be cancelled? Sin terms will be get cancelled. Then you get 2 cos m alpha plus n beta. That's all. Hence proved this is. In similarly, first question is over. Then second question is to x power m into y power n minus 1 by x power m into y power n. Nothing but same thing, right? But in between minus is there. M alpha plus n beta plus I into sin of m alpha plus n beta, and minus is there na, first term will be changing into minus, second term will be changing into plus I sin m alpha plus n beta. Now which terms will be get cancelled? Cos terms will be get cancelled. Then you get 2I sin m alpha plus n beta. That's all. We proved this and this we proved. Just adding the both terms, what we got. So plus in between, so adding, sin term will be cancelled. If it is subtracting, then cos term will be cancelled. That's all. Then go to the next question in the same thing all. Question number 7th. Question number 7, A bit is given and B bit is given. So that is nth roots of a complex number in based on this question. So that is question number 7. Question number 7, that is question number 7, A bit, solve it is given x power 9 minus x power 5 plus x power 4 minus 1 equal to 0. This is the first question, and B bit also given same, but it in the form of 11th degree. So solve the equation as x power 9. So 9th degree means this equation, if it is quadratic means number of roots are 2, and if it is cubic means number of roots are 3. But in the question it is given that in the form of x power 9. So we have to we can get as number of roots are as to 9. So it's solving, that is when solve means you have to prove x equal to, that's all. So that is why I am taking simplification we have to take, that is solution x power 9 minus x power 5 plus x power 4 minus 1 equal to 0. From these two terms, x power 5, this from these two terms x power 5 is common. Then you write x power 4 minus 1. Here x power 4 minus 1 equal to 0. So taking common as x power 4 minus general factorization, x power 5 plus 1 equal to 0. Then you get r. Therefore we get x power 4 minus 1 equal to 0, and another one is x power 5 plus 1 equal to 0. So that is write as x power 4 equal to 1. It is also x power 5 equal to minus 1. So total terms are x is, find out x equal to, write as here 1 to the power of 1 by 4. That is 1 power as 4 terms. Number of roots minus 1 while having 5 roots. Now simplify in the nth roots of unity formula. So what we have done, general factorization, x power 9 minus x power 5 plus x power 4 minus 1 equal to 0. From these two terms we can, x power 5 is common. From these two terms same and keep it as same. So x power 5 plus 1, it is x power 4 minus 1. Product of the two terms, that is x power 4 minus 1 equal to 0 and x power 5 plus 1 equal to 0. That is making that. So x power 4 equal to 1. So we have to prove x equal to 1 to the power of 1 by 4. That means in the fourth roots of 1 we have to find. Here x power 5 equal to minus 1, nothing but x equal to minus 1 whole to the power of 1. So here find out fifth roots of minus 1. Then becomes to total here 4, here 5 means totally get 9 roots. So that the question is also in the 9 roots. So this is why I am taking next page. So that is find out the x equal to, first write as x equal to 1 to the power of 1 by 4 roots. That meaning that, so 1 has the power 4th roots. This means proved in the form. So that is nothing but 1 replace as 2. We can write as in the sys form, that is always sys 0 whole to the power of 1 by 4. So it represents 4 values. It is nth roots of q, nth roots of unity formula. Sys theta whole to the power of 1 by n formula we can write as sys of 2k pi plus theta by n whole to the power of, where k equal to write as, where k equal to 0, 1, 2, so on up to write as, no need write n minus 1 term. This is the basic find out the nth roots of unity formula. So don't forget, any number represent as in the sys form. That is why I am writing 1 here, sys 0 whole to the power of 1 by. Now it is in the form of sys theta whole to the power of 1 by n, that is sys of 2k pi plus theta by n, where k equal to 0, 1, 2, so on up to n minus 0 is included. So where k is the integer, starting with 0, write as up to last term is meaning that n minus 1. So k is always integer. So now substitute where theta is equal to 0 and n represents 4. So here represents 4 values, that is sys of, write in the formula 2k pi plus theta means 0 by n means write as 4, where k equal to write as 0, number of roots 0, 1, 2, 3 represents a 4 values. That is why write as to this. So sys of 2k pi means 2k pi by 2. So k pi by 2 where k equal to write as 0, 1, 2, 3. Now substituting this is the value for x. Now write as, put k equal to first value k equal to 0, write as x equal to, we get sys 0 into pi by 2 means sys 0, that is nothing but 1. Sys 0 is always 1, and put x equal k equal to 1, we can write as x equal to 1, nothing but sys pi by 2. Already we learned total how many values, that is equal to I. If k equal to 2 write as, then you write x equal to 2k sys of 2 pi by 2, nothing but sys pi. Sys pi meaning that, that is minus 1. If k equal to 3 write as, so that is x equal to sys of 3 pi by 2, or else sys of 3 by 2 by 3 pi by 2 nothing but in anti-clockwise. So it we can write as positive means sys minus pi by 2, nothing but this becomes to minus I. So this is the roots. What are the roots? 1, minus 1, I, minus I. These are the 4th roots of unity. In the similar way, in the previous, we can x equal to 1 to the power of 1 by 4. In the similarly, x equal to minus 1 to the power of 1 by 5, and the 5th roots of unity. So write in this here, x equal to minus 1 whole to the power of 1 by 5. Now find it 5th roots of unity by using this formula. So that is nothing but minus 1 write as, minus 1 nothing but what? Sys pi. So sys pi, don't forget this, all is every important objective also. 5th power 1/5 represents 5 values. So it is in the form of same thing, that is in the form of sys theta whole to the power of 1 by n. So that is sys of 2k pi plus theta, theta means pi, by n means write as 5, where k equal to, number represents 5 values, nothing but starting with 0 writing up to 5 terms. So 1, 0, 1, 2, 3, 4. Number of terms are 5, represents the 5 values. That's why we are writing. So in this x equal to write as sys of, we can write simplify 2k plus 1 into pi by 5, where k equal to 0, 1, 2, 3, 4. If k equal to 0 write in this, then you get x equal to 6 pi by 5, 1 of the root. And if put k equal to 1 here, so x equal to write as sys of 1 here, k 2 into 1 plus 1, that is nothing but 3 pi by 5. And next k equal to write in this question, x equal to sys nothing but sys 2 means write 2 to the 4 plus 1. So 5, and this is nothing but sys pi. So common root is there. Sys k equal to 3 nothing but x equal to sys of 7 pi by 5. So nothing but k equal to last term, that is x equal to 4 means write as sys of 4 to the 8 plus 1, 9, 9 pi by 5. So therefore, last step very important in the question. The roots of the given equation, right? Last given equation are, what are the roots? Totally we got 9. 9 we have to write. Plus or minus 1, plus or minus I, this plus 1 minus 1, plus or minus I, and all this. Write all this as it is. 6 pi by 5 and 6 of 3 pi by 5 and 6 of pi. Repeated in 7 pi by 5 we write. 7 pi by 5. So 6 9 pi by 5. So these are the roots of the equation. So that is in the form of fourth roots of unity and the minus 1 fifth roots of minus 1. We have to using this basic formula you could write as all these equation roots. In the same way, question number B with is also same question. Find all the roots of the equation x power 11. Same method, same continuation. So all of you write. So that is in the find all the roots of the equation x power 11 minus x power 7 plus x power 4 minus 1 equal to 0. Based on this roots of unity form. But in the question in previous x power 9, now we have to find x power 9. Total roots are here, 11 roots will be there. So write as in the next page. Question number 7, B with. Question number 7, B with. Question number 7, B with. Find all the roots. Find all the roots of the equation x power 11 minus x power 11 minus x power 7 plus x power 4 minus 1 equal to 0. So that is the question. Same previous method solving. So that is the solution. First general factorization method. That is write as x power 11 given as x power 11 x power 4 plus x power 4 minus 1 equal to 0. From this both terms we have to common x power 7, then you get x power 4 minus 1. From this we can write as x power 4 minus 1 equal to 0. So that is x power 4 minus 1 is common, then you get x power 7 plus 1 equal to 0. So that is x power 4 minus 1 equal to 0 or x power 7 plus 1 equal to 0. So nothing but in previous only we got that is 1. So nothing but 1 to the power of 1 by 4. And similarly this is as to x power 7 equal to minus 1. Then x equal to write as minus 1 whole to the power of 1 by 7. Now previously we have completed this. But in replace here 7 is here 7 term. Nothing but represents the 7 values. Find out the nth 7 roots of the minus 1. So same thing write as x equal to write as 0 whole to the power of 1 by 4. Nothing but it is in the form of 6 theta whole to the power of 6 theta whole to the power of 1 by n. 6 theta whole to the power of 1 by n nothing but 6 of 2k pi plus theta by n, where k equal to 0, 1, 2, 3, so on n minus 1. So this formula must be right here anyway, don't get confused. So that is 6 0 means 6 of 2k pi plus theta means 0 by 4 repeated same form. That is k equal to 0, 1, 2, 3. So nothing but 6 of k pi by 2. K pi by 2 nothing but say k equal to, write as where k equal to 0, 1, 2 represent with as to 0 number of terms are roots are 4. So replace where x put x equal to k equal to 0, 1 of the value, k equal to 1, k equal to 3, that is right. So I am writing here put x equal to 0, that implies 6 0, that is 1. Put x equal to 1, write as 6 pi by 2, that is meaning that I. X equal to 2, write as 6 pi, that is minus 1. X equal to 3, that implies 6 to 3 pi by 2, or else 6 of minus. Anti-clockwise you get minus I. 3 pi by 2, so 270. Remaining angle 3 minus pi by 2, and clockwise direction. So that is minus I. That is why angle it has to minus I. Here how many roots? 1 plus or minus 1 plus or minus I. Total roots are 4. Similarly, this minus 1 having the power roots are 7. So, 7th roots of minus 1 we have to prove in the next page. That is as to x equal to minus 1 whole to the power of 1 by 7. In this minus 1 write as 6 pi whole to the power of, in previous problem this is converted as 5th power. Now we have to find out 7th power. That is same thing. 6 of 2k pi plus theta means pi here angle, n means 7, where k equal to write as 0, 1, 2, 3, 4, 5 up to 6. Number of terms is 7. So substitute 6 of 2k plus 1 into pi by 7. So where k equal to 0, 1, 2, 3, 4, 5, 6. Put x equal to 0 in this term, then 6 of pi by 7. Put x equal, not k, this is k nana, k equal to 1, that is 6 of, k equal to 1 means 6, 1, 2 plus 1, that is 6, 3 pi by 7. K equal to 2, nothing but, so that is 6, 5 pi by 7. So k equal to 3, that is 6 of 7 pi by 7 means 7. K equal to 4, k equal to 4 you write, k equal to 4 means 6 of 4 to the 8 plus 1, 9 pi by 7. K equal to 5, so 6 of 11 pi by 7. So k equal to 6 last term, so that is 6 to the 12, 13 pi by 7. Therefore these are all 7 roots. In previously 4 terms, 4 roots. So therefore we can write all the roots are given in the question. Therefore all the roots of the given equation is plus or minus 1, plus or minus I, and total value always write as 1 by 1. 6 pi by 7, 6 3 pi by 7, 6 5 pi by 7, and 6 pi is common, 6 pi 9 pi by 7, and 6 of 11 pi by 7, and 6 of 13 pi by 7. That's all. That is the total all roots of the given equation. This carries also 7 marks. So out of this 13 question you practice very well. This is only another way method. Then go to the next question, question number 8, very easiest question. So that is question number 9, first bit, second bit is over. Then question number 8. So write in the next page. Question number 8, very easiest question. Show that one value of this. So show that one value of this 1 plus sine pi by 8 plus I cos pi by 8 divided by 1 plus sine pi by 8 minus I cos pi by 8 whole to the power of 8 by 3. Already explained in the exercise problem, it is equal to minus 1. Show that one of the values. So it represents how many values here? 3 roots. 8 by 3 means 8 in suppose. So denominator term 3. So this expression should have the containing 3 roots. If it is one of the value is minus 1, we have to prove. So this is always based on the trigonometry formula. So first see the question properly. So that is always I is associated with only for sine. Here given that I in terms of I into cos pi by 8. So converting here to important. So conversion means sine has to change as to cos, cos has changed as to sine. That is why I am writing basic formula, that is sine 90 minus theta equal to cos theta. Cos 90 minus theta equal to sine theta. This is basic formula. So write as this one, I am applying this one here. So that is sine 90 minus theta equal to cos theta. Cos 90 minus theta equal to sine theta. This applying. Why? Because here this has to, in terms of I is associated with cos. That's when we are converting. So that is meaning that, so 1 plus given as sine pi by 8 plus I cos pi by 8 by 1 plus sin pi by 8 minus I cos pi by 8. Why we are changing? Why? Because don't always I is associated with the cos, only for sin. So that's why I am rechanging, converting as sin theta equal to cos 90 minus theta. So cos of 90 minus theta writing. Similarly cos theta nothing but sin 90 minus theta writing. Sin 90 minus theta, sin of 90 minus theta. Why? Because all these has to 1 plus cos 90 minus theta plus minus I is there, minus I into sin of 90 minus theta whole to the power of 8 by 3 is given. So that is 1 plus, now becomes to pi by 2 minus pi by 8 simplification, that is you get in terms of angle, that is 3 pi by 8. So write as 1 plus cos 3 pi by 8 here plus I sin 3 pi by 8. Angle value simplification, that is 1 plus cos 3 pi by 8 minus I sin 3 pi by 8. Same thing you write, just replace by plus or in the question is given, that is 8 by 3. So that is first converting into sin as to cos as to sin, cos sin as to cos. And so writing this one, now it is in the 1 plus cos theta form here. 1 plus cos theta form, that is 2 cos squared in the first question we learn this. So sin theta is nothing but 2 sin theta by 2 cos theta by 2. So this basic formulas is apply here for 1 plus cos 3 pi by 8 and sin 3 pi by 8, these total values. So 1 plus cos 3 pi by 8, I am applying this 1 plus cos 3 by 8 to this formula and sin 3 pi by 8 as to this formula. So that is I am writing in the next page. So that is 1 plus cos 3 pi by 8 nothing but 2 cos square 3 pi by 16 plus 2 into 2 sin is there, so right I is common outside. So sin theta, sin 3 pi by 8 nothing but 2 sin 3 pi by 16 into cos 3 pi by 16. In similarly denominator has to write as 2 cos square 3 pi by 16, same thing just replace by plus as in between. I into 2 sin 3 pi by 16 into cos 3 pi by 16. So that is this has to put equal to here. Now numerator we get this, all these in the power of 8 by 3 given. For numerator 2 cos 3 pi by 16 is common. So that is cos 3 pi by 16 plus I sin 3 pi by 16. Increase same thing as to denominator 2 cos 3 pi by 16 into cos of 3 pi by 16 minus I sin 3 pi by 16 whole to the power of 8 as 8 by 3. So these two terms will be cancelled. Now it is in the Demoivre. So just replace by here 8 by 3 given na. So write as in terms of, so nothing but this cos 3 pi by 16 into 8 by 3 plus I into sin of 3 pi by 16 into 8 by 3 divided by same thing cos 3 pi by 16 into 8 by 3 minus I into sin of 3 pi by 16 into 8 by 3. Just simplify, 3 cancel. So that is cos, this has to go to cos pi by 2. Cos pi by 2 plus I sin pi by 2 divided by cos pi by 2 minus I sin pi by 2. Nothing but this has to write as cis pi by 2. Cis pi by 2 divided by cis of minus pi by 2. It is in the form cis alpha by cis beta, nothing but cis pi nothing but minus 1. Now hence proved. So just practice all this, Nana. So remaining I will explain tomorrow. Okay. Thank you.